Dear students, welcome to the study of P block elements. We are learning carbon family, that is group number 14 elements. This is the fourth part of our P block elements study. In the previous three parts, we discussed boron family group number 13 as well as we studied group number 14, that's carbon family, some properties. Okay, so we will continue with the study of group number 14, carbon family. Today we will learn one very important concept as far as your theory examinations, even competitive examination is concerned, that is allotropes of carbon. ಕನ್ನಡದಲ್ಲಿ ಏನಂತಾರೆ, ಇಂಗಾಲದ ಬಹುರೂಪತೆಗಳು, allotropes of carbon we are learning. There are many allotropes of carbon are there. We are concentrating or we are learning in this lesson the three allotropes of carbon. They are diamond, graphite as well as fullerenes. We are going to learn in this part. Okay, what's the meaning of the term allotropy? What is meant by allotrope, allotropes, allotropy? Okay, I hope you might have studied this concept in a 10th class. ಲೋವರ್ ಕ್ಲಾಸಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ. ಅದು ನೋಡೋಣ. ವಾಟ್ಸ್ ಮೀನ್ಡ್ ಬೈ ಅಲಾಟ್ರೋಪಿ, ಬಹುರೂಪತೆಗಳು ಅಂದರೇನು? ಅಲಾಟ್ರೋಪಿ it is the property of elements. Two or more than two forms of an element having different physical properties but same chemical properties are known as allotropes of that element, and such condition of an element is called as allotropy. Okay, so in simple words, allotropy means these are the two or more different forms of the element. Those forms are physically different. They have different physical characters, properties, but chemically they are same, but same chemical properties they possess. Such different forms of an element are known as allotropes, and the property is called as allotropy. ಅಂದರೆ ಬೇರೆ ಬೇರೆ ಫಾರ್ಮ್ಸ್, ಒಂದು ಎಲಿಮೆಂಟ್ ಅದು ಬೇರೆ ಬೇರೆ ಫಾರ್ಮ್ಸ್ ಅಲ್ಲಿ ಏನಿರ್ತದೆ ಅಂತಂದ್ರೆ ಅವೆಲ್ಲ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ, ಭೌತಿಕ ಗುಣಲಕ್ಷಣಗಳು ಬೇರೆ ಬೇರೆ ಇರ್ತವೆ, ಬಟ್ ಕೆಮಿಕಲಿ ದೇ ವಿಲ್ ಬಿ ಸೇಮ್. ಸಚ್ ಫಾರ್ಮ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಇನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ಸೊ ಐ ಹೋಪ್ what's allotropy is clear to you. Okay, allotropy is the phenomenon of an element in which two or more different forms of the element have different physical properties but chemically they are same. Okay, carbon has mainly two types of allotropes. They are crystalline allotropes and amorphous allotropes. Okay, and this classification is done mainly based on their crystalline structure, crystalline lattice. Okay, crystalline and amorphous allotropes of carbon are seen. Again, the crystalline allotropes are diamond, graphite, fullerenes and CNTs. They are called as carbon nanotubes. These are crystalline forms of allotropy, whereas amorphous forms of allotropes of carbon are coke, carbon black, charcoal, etc. Okay, so that means carbon found in both crystalline allotropy as well as amorphous allotropic forms. In this lesson, we are learning the three crystalline allotropes of carbon. We are learning diamond, graphite and fullerenes. Okay, fine. First allotrope of carbon is diamond. Diamond has a crystalline lattice. It has a very strong crystalline structure, and in a diamond, I said diamond is an allotropic form of carbon. That means it contains exclusively carbon atoms. It contains only carbon atoms, no hydrogen, no oxygen, nothing. ಓಕೆ, ಕಾರ್ಬನ್ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ಇರೋದಿಲ್ಲ ಅಲಾಟ್ರೋಪ್ಸ್ದಲ್ಲಿ, ಕಾರ್ಬನ್ ಅಲಾಟ್ರೋಪ್ಸ್ದಲ್ಲಿ. ಓಕೆ, ಇನ್ ಡೈಮಂಡ್ ಈಚ್ ಕಾರ್ಬನ್ atom undergo sp3 hybridization. Therefore, we get 4 hybrid orbitals, and each carbon is linked to 4 other carbon atoms in a tetrahedral manner, in a tetrahedral fashion. Okay, you can see here, say if you consider this this blue color dot as a carbon, this carbon in a diamond undergo sp3 hybridization, and each carbon is bonded to how many other carbon atoms? 4 other carbon atoms in a what kind of a fashion? In a tetrahedral fashion, in a tetrahedral manner. And in a diamond, the carbon-carbon bond length is found to be 154 picometer. And this structure of diamond, the crystalline lattice of diamond is a rigid diamond. It's a rigid substance. This structure produces a rigid three-dimensional network of carbon atoms. Okay, each carbon atom undergoes sp3 hybridization. Each carbon atom bonds with the 4 other neighboring carbon atoms, forming a tetrahedral manner, and this structure produces a three-dimensional rigid network of carbon atoms. And diamond is a very hardest substance on the earth, because it is very much difficult to break the extended covalent bonds in case of diamond, and therefore diamond is said to be hardest substance on the earth. The reason is the carbon atoms are very small. We studied in previous class. Carbon atom is very small. Carbon has the property of catenation. Carbon-carbon bond length will be very strong. Okay, and because of all these points, it's very difficult to break this carbon-carbon covalent bonding. Diamond is said to be hardest substance. And this diamond is used as an abrasive for sharpening of hard tools. Even it's used in cutting of glasses, cutting of metals, cutting of glasses. Okay, and even this diamond is used in the manufacture of tungsten filaments, which are used in electrical light bulbs. Okay, the important property, first of all, it's a crystalline lattice. It's a three-dimensional rigid network of carbon atoms. Each carbon atom undergoes sp3 hybridization. Each carbon bonded to 4 other neighboring carbon atoms in a tetrahedral fashion, and bond length is 154 picometer. Diamond is hardest substance. Clear? Okay. We'll move to the next allotrope, graphite. This graphite is again a crystalline allotrope which are used in these pencils. Pencils are made up of what? Graphite allotrope. Graphite, it has a layered structure. Diamond has a three-dimensional structure, whereas graphite has a two-dimensional layered structure. And these layers, are held by a weak van der Waals force of attraction, and the layers are separated by a distance of 340 picometer scale. Okay, look at this diagram. Here, this is one layer, this is another, and this one is the third layer. Graphite contains a layered structure, and between this layer and this layer there is no chemical bond, there is no covalent bond. These layers are held by van der Waals force of attraction. Between this layer and this layer, van der Waals force of attraction is there. Between this layer, again this layer, attraction is there, and these layers are separated by certain distance, that's of 340 picometer. ಅಂದ್ರೆ ಈ ಲೇಯರ್ ಮತ್ತು ಈ ಲೇಯರ್ ನಡುವೆ 340 picometer ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ. ಆಮೇಲೆ ಎರಡು ಲೇಯರ್ ನಡುವೆ ಏನಿದೆ? ವೀಕ್ van der Waals force of attraction ಇದೆ. Hence graphite has a two-dimensional layered structure. And each layer is composed of planar hexagonal rings of carbon atoms. Okay, so ಈಗ ಲೇಯರ್ ಇರ್ತವೆ, ಲೇಯರ್ ಅಲ್ಲಿ ಏನಿದೆ? ಪ್ರತಿಯೊಂದು ಲೇಯರ್ದಲ್ಲಿ hexagonal rings of carbon atoms are there. A 6-membered rings of carbon atoms are there. Can you see this structure over here? So if you consider this as one ring, in this layer this is one ring. So this is 1, 2, 3, 4, 5, 6. How many membered ring structure it is? It's a 6-membered ring structure. The ring is planar. It's a hexagonal ring structure. Okay, and this ring is attached to another ring. That ring attached to another ring. It contains many planar hexagonal rings of carbon atoms. In graphite, each carbon atom in a hexagonal ring undergoes sp2 hybridization. Okay, diamond allenide, in diamond carbon atom undergo sp3 hybridization, whereas in graphite each carbon atom undergo sp2 hybridization, produces 3 hybrid orbitals and makes 3 sigma bonds with a 3 neighboring carbon atoms. Okay, that means what? Here these blue dots indicates a carbon atom. Carbon atom undergo sp2 hybridization. Each carbon is bonded to how many neighboring carbon atoms? 3 neighboring carbon atoms. Consider this one. Okay, look here. Idin tagondre this carbon is bonded to this carbon and this carbon. Andre ಒಂದು ಕಾರ್ಬನ್ ನೇಬರಿಂಗ್ 3 ಕಾರ್ಬನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗಿರ್ತದೆ ಗ್ರಾಫೈಟ್ ಅಲ್ಲಿ. ಅದೇ ಡೈಮಂಡ್ ಅಲ್ಲಿ ಒಂದು ಕಾರ್ಬನ್ 4 ಕಾರ್ಬನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗಿರ್ತದೆ. And the 4th electron, no, it's a free and it forms a pi bond within this ring, no. So 1 carbon atom form a 3 neighboring carbon atom ಜೊತೆ covalent bond form ಮಾಡ್ತದೆ. The 4th carbon forms a pi bond between the carbon atoms. And the carbon-carbon bond length is said to be 141.5 picometer, lesser than that of a bond length in case of diamond. Diamond kintano ಇಲ್ಲಿ carbon-carbon bond length ಕಡಿಮೆ ಇರ್ತದೆ, 141.5 picometer. Again, due to what? Due to the formation of a partial double bond character. The 4th electron forms a pi bond, no? ಅದರಿಂದ ಈ bond length ಕಡಿಮೆ ಆಗ್ತದೆ. And you know, the 4th electron form a pi bond. This electron is delocalized over the whole sheet and electrons are mobile in this layer, no. Each carbon atom has a one free electron. Okay, so those electrons are moving within this planar hexagonal rings. These electrons are mobile, they are moving. Therefore, graphite conducts electricity along the sheet. Graphite conducts electricity due to the movement of electrons. Due to the mobile electrons, graphite conducts electricity. Whereas in case of diamond, there is no free electron. All the electrons of an atom, carbon atom, are involved in a bond formation. Hence, diamond do not conduct electricity, whereas graphite conducts electricity. And you know, graphite cleaves easily between the layers. I said, you know, these layers are held by van der Waals force of attraction and these layers are cleaved, broken very easily. Therefore, graphite is said to be very soft and slippery. In graphite also, carbon-carbon bond is very strong. Carbon-carbon bond is strong, but due to the presence of a layered structure, due to the presence of weak van der Waals force of attraction between the layers, layers will cleave, layers will break. Hence, andre ಈ layer ನಡುವೆ ಏನಾಗ್ತದೆ, weak force ಇರೋದ್ರಿಂದ ಅವೆರಡು layer break ಆಗ್ತವೆ. Layers break ಆಗ್ತವೆ, bonds break ಆಗೋದಿಲ್ಲ. Bonds are very strong. Due to the breaking of these layers, graphite is said to be a bit soft, very softer, and it is slippery in nature. Okay, and because of this reason, graphite is used as a dry lubricant in automobile industry, in machines which are running at a higher temperature. No, graphite acts as a lubricant due to its slippery nature. Okay, this is about properties of graphite. So summary helodadre, graphite has a layered structure. Layers are held by van der Waals force of attraction. Layers are separated by 340 picometer. Layer ಅಲ್ಲಿ ಏನಿದೆ, each layer has 6 membered rings of carbon atoms. ಹೌದಾ? ಸೊ ಆ ರಿಂಗ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ atoms undergo sp2 hybridization. Each carbon bonded to 3 other carbon atoms with a sigma bond, and the fourth electron form a pi bond. And since the electrons are delocalized, they are moving, graphite conducts electricity. Due to the layer structure, graphite is said to be very soft and slippery. Clear? Okay. So these are two allotropes of carbon, diamond and graphite. Okay, fine. This is an important concept. Differences between diamond and graphite. Any difference idave? Diamond is a 3-dimensional network, rigid network of carbon atoms. Whereas diamond, it's a 2-dimensional layered structure. It's one of the difference between diamond and graphite allotrope. And in diamond, carbon atom undergo which type of hybridization? sp3. Whereas in graphite, carbon atom undergo sp2 hybridization. In case of diamond, carbon-carbon bond length is 154 picometer, whereas in graphite, carbon-carbon bond length is 141.5 picometer. Diamond is said to be hardest substance, whereas graphite, due to layer structure, no, it's very soft and slippery. And diamond do not conduct electricity, whereas due to the presence of mobile electrons, graphite conducts electricity. These are few differences between the diamond and graphite allotropes of carbon. Okay, yes, fine. We'll move to the next allotropy. Before moving to the next allotropy, it's a reminder for you. This is the 4th part of P block elements study, and it's the last part. With this allotrope, no, the P block element chapter will be completed. In previous part also I have said you that you need to go through all the videos, all the 4 parts of P block element study. You need to take down the notes in a notebook. When you come back to the college, I am going to check that notes. Okay, so this is a reminder. And if you like my video, subscribe to my YouTube channel. Okay, just click the subscribe button which is there just besides my name. Okay, subscribe to my YouTube channel and share these videos to your friends. Okay, last allotropy of carbon. Okay, ಇನ್ನು ಇದಾವೆ, ಬಟ್ ನಮ್ಮ ಲೆಸನ್ದಲ್ಲಿ ಇರೋದು ಇದು 3. Fullerenes. Fullerene is also a crystalline allotropy, and the different types of fullerenes are there. Fullerene C60 and even Fullerene C70. We are learning Fullerene C60 in this concept. And it's the most famous Fullerene, Fullerene C60. It's an allotrope. Andre ಇದರಲ್ಲಿ ಏನಿರ್ತದೆ, it's a form of a carbon ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ atom element ಇರೋದಿಲ್ಲ. Carbon allotropy it is. This Fullerene, discovered by H.W. Croto and R. Smalley. They are from Rice University of USA. In the year 1985, this Fullerene allotropy is discovered. And popularly, this Fullerene is known as Buckminster Fullerene or Buckminster Fuller, because this name is given in honor of an American architect. His name is Buckminster Fuller. Okay, so in the honor of this Buckminster Fuller, these are called as Fullerenes, and even these are called buckyballs, because the shape of this C60, it resembles the dome structure. Okay, you can see here, it resembles the dome structures on hexagons and pentagons designed by this book minister Fuller. And even these Fullerene structure, no, they looks like a soccer ball. They looks like a football, isn't it? Okay, not big as football. They are very minute microscopic structures, but the structure looks like a soccer ball or football. Okay, discovered by Croto and Smalley, but given the name Fullerene in the honor of an architect, book minister Fuller. Yes, we'll see few properties of this Fullerene, mainly Fullerene C60. These Fullerenes, no, they are made by heating another allotrope of carbon, that's a graphite, in an electric arc in the presence of inert gases such as helium or argon. So, in the presence of helium or argon, if graphite is heated in electric arc, no, that graphite allotropic form gets converted into Fullerene allotropic form. And these Fullerenes are cage-like molecules. You can see in this diagram, cage-like molecules. They are Fullerene C60, no? It has a shape of a soccer ball. Just I said, you know, it has a shape like a football, and it's called book minister Fullerene. This Fullerene C60 contain 26 membered rings, 20 hexagonal rings, and 12 5-membered rings. Can you see here? This Fullerene contain 6-membered rings as well as 5-membered rings. Both are there. So in Fullerene C60, we have exactly 26 membered rings and 12 5-membered rings we can come across in Fullerene C60. And you know, in this Fullerene, a 6-membered ring is fused with a 6-membered ring, or a 6-membered ring is fused with a 5-membered ring. ಅಂದ್ರೆ 6-membered ring ಮತ್ತೊಂದು 6-membered ring ಜೊತೆ ಫ್ಯೂಸ್ ಆಗಿರ್ತದೆ, ಅಥವಾ ಆ 6-membered ring ಮತ್ತೊಂದು 5-membered ring ಜೊತೆ ಫ್ಯೂಸ್ ಆಗಿರ್ತದೆ. ಬಟ್ ಯು ಕ್ಯಾನ್ ನಾಟ್ ಕಮ್ ಅಕ್ರಾಸ್ 5-membered ring ಫ್ಯೂಷನ್ ಇನ್ ಕೇಸ್ ಆಫ್ Fullerene C60. ಅದು ಕಂಡು ಬರುವುದಿಲ್ಲ ನಮಗೆ. ಅಂದ್ರೆ a 6-membered rings can fuse with 6-membered ring or 6-membered with a 5-membered ring, but there is no 5-membered ring is seen in case of Fullerene. Again in Fullerene, each carbon atom undergo sp2 hybridization, and each carbon forms 3 sigma bonds with a neighboring 3 carbon atoms. The remaining electron, no, 4th electron on each carbon atom is delocalized in a molecular orbital, which in turn give a kind of aromatic character to this molecule. And this Fullerene ball-shaped molecule has 60 vertices. Fullerene C60 anta ಹೆಸರು ಯಾಕೆ ಬಂತು? Due to the presence of 60 vertices in a ball-shaped molecule, and which contain both single and double bonds with a carbon-carbon bond length of 143.5 picometer. That's a single bond length, and a carbon-carbon double bond length of 138.3 picometer. And these spherical Fullerenes, no, they are also called as buckyballs in short. Okay, so this is the third allotropic form of carbon, which is mentioned in our syllabus for the study in this P block elements lesson. Okay, so this is Fullerene C60. Remember that each carbon atom undergo sp2 hybridization, has 60 vertices, 26 membered rings are there, and 12 5-membered rings are there. A 6-membered fusion is there, or 6-membered 5-membered ring fusion is there, but there is no 5-membered ring fusion is seen in this Fullerene. Okay, with this we completed the study of allotropes of carbon. With this we completed the study of group number 14 elements. Adar jotege we completed the study of P block elements lesson. So far I completed my portion allotted to me for this academic year. Okay, so far we covered classification of elements and periodicity in properties, first lesson. Later we studied redox reactions, then hydrogen, S block elements, and last one is P block elements. Okay, thank you very much.